Hello student, again we are here with the fifth topic of chapter number 2 related to basic mechanical engineering. The title is property of gases. So in this video we have to discuss about polytropic process. Three different processes we had already discussed. You can refer these processes using this YouTube channel AVM Tech Android, or you can scan this QR code and you can enjoy the free videos. So now we have to talk about polytropic process. So polytropic process is a general thermodynamic process which follows PV raised to n equals to constant, where P is the pressure, V is the volume and n is the polytropic index, that is a constant. And this is a PV diagram for this PV raised to n equals to constant process. So here very important thing which you can see is when n is 0, your process is a constant pressure process. When n equals to 1, the process is PV equals to constant, that is isothermal process. When n equals to gamma, that is adiabatic index, your process is adiabatic process, that is our next video. And when n is equals to infinite, what we will see, V is constant, that is a constant volume process, or it is a isochoric process. So this is a very important process as per the thermodynamic is concerned. Now, as we know, the basic equation for the polytropic process is P raised to n equals to constant, or you can say P1 V1 raised to n equals to P2 V2 raised to n, that is equals to constant, or you can say this P, that is equals to C divided by V raised to n. Now we want to find out what is the work done for this process. So work done during the process, as usual, the formula W, that is equals to integration between initial state V1 to final state V2 PdV. So what is the P value? That is C divided by V raised to n. So we, instead of P, we have to put C divided by V raised to n. So what we'll observe here is C is constant, this C is constant, and that is coming here. So W, that is equals to C integration between V1 to V2 V raised to minus n into dV. And when n is not equals to 1, in that case W, that is equals to C divided by 1 minus n into bracket V2 raised to 1 minus n minus V1 raised to 1 minus n. And as we know, PV raised to n is equals to constant, P1 V1 raised to n, that is equals to P2 V2 raised to n, that is equals to constant, that is known to us. So now what we have to do is we have to put the value of C in the above equation. So we will get work done, that is P2 V2 minus P1 V1 divided by 1 upon n, where n is a polytropic index. So our final expression for work done in case of polytropic process where n is not equals to 1, it is P2V2 minus P1V1 divided by 1 minus n. And if n equals to 1, it is isothermal process, and we know W, that is equals to MRT ln V2 by V1, or it is P1V1 ln V2 by V1, or it is P2V2 ln V2 by V1, which is known to us. So once this work done is available, we have to find out what is the change in internal energy. So change in internal energy, that is mCV T2 minus T1. We know PV, that is equals to MRT, or that is equals to, you can say P1 P2V2 minus P1V1, that is equals to MR T2 minus T1. So what we are doing is we just want to find out what is the value of T2 minus T1, because that we have to place here. So I am replacing this T2 minus T1 by this equation. So change in internal energy, that is equals to this M cancel, that is CV by R, that is CV by R into P2V2 minus P1V1. What is available here? That is mentioned here. Okay. So this is an important relation connecting heat transfer and work done. Now, one important thing again which we have to discuss, that is relationship between temperature and volume. This is a very important relation. So PV raised to n is equals to constant and PV equals to MRT. So when we will put T, that is equals to PV divided by MR, and when we use C divided by V raised to n, that is equals to P, we will get T2 by T1, that is equals to V1 by V2 raised to n minus 1. We must remember this equation. This is very helpful to solve the numerical. In this similar way, whenever we have to find out the relationship between temperature and pressure, we can say PV raised to n is equals to constant and PV equals to MRT. So based on that, we will get the relation T2 divided by T1, that is equals to P2 divided by P1 raised to n minus 1 upon n. And the relationship between the pressure and volume is P1 V1 raised to n, that is equals to P2 V2 raised to n, that is equals to constant. So the relationship between P, V and T, that is very important, and that we had discussed. So this is end about all the formulas related to polytropic process. This is a conclusion what we did. So the process law, that is PV raised to n, is constant. Work done, that is W for n not equals to 1, that is P2V2 minus P1V1 divided by 1 minus n. Internal energy delta U, that is mCV T2 minus T1, it is depend upon delta T. Heat supplied Q, that is equals to n minus gamma divided by n minus 1 into W, that is the main relation. The relationship between temperature and volume, that is T2 by T1, that is equals to V1 divided by V2 raised to n minus 1. The relationship between the temperature and pressure, that is T2 by T1, that is equals to P2 by P1 raised to n minus 1 upon n. And the relationship between P and V is P1 V1 raised to n, that is equals to P2 V2 raised to n. So these all are, you can say, formulas which you have to either remember or you have to derive. It is better you understand the procedure to derive the formula, so easily you can derive and there is no need to remember it. But these formulas are very important to solve the numerical for the basic mechanical engineering. So now let us solve one numerical. So 1 kg of air undergoes a polytropic process. PV raised to 1.2 is constant. Initial pressure is 100 kilopascal. Initial volume is 0.1 meter cube. Final volume is 0.2 meter cube. R value is 0.287 kilojoule per kilogram Kelvin. CV value is 0.718 kilojoule per kilogram. Find out the work done and it's applied. It may possible that they may ask you find out delta U also, that is change in internal energy. So this question may be of 7 mark in that case. So here mass is given, that is 1 kg. PV raised to 1.2 is constant. Initial pressure is given. Volumes are available. R value is given. CV value is given. We have to find out work done and heat supplied. So first is the work done part. So W, that is equals to P2V2 minus P1V1 divided by 1 minus n. So first we find out what is the value of P2. So we know the relationship between P and V, that is P1 V1 raised to n, that is equals to P2 V2 raised to n. This n value is 1.2. So P2, that is 100 into bracket 0.1 divided by 0.2 raised to 1.2. So we'll get P2 value, that is 43.5 kilopascal. Unit is very important. You must write the unit correctly. So when P2 is available, V2 is also known to us, P1 V1 is given in the data, n value is 1.2. So we will get W, that is with minus 1.3 divided by minus zero point 0.2, that is 6.5 kilojoule. So the W value which we will get, that is positive one, that is 6.5 kilojoule. Now the next task is to find out heat supplied Q. That is N minus gamma divided by N minus 1 into W. Gamma is 1.4, that is known to us. N value is 1.2. So 1.2 minus 1.4 divided by 1.2 minus 1 into the value of W, that is 6.5. So we will get the value of Q, that is negative minus 6.5 kilojoule. But in the final answer you cannot write Q equals to minus 6.5 kilojoule. What you have to write in the answer is the W value, that is 6.5 kilojoule, and the Q value is, what you can say, Q value is 6.5 kilojoule, heat is rejected. So you have to write the answer Q equals to 6.5. You should not write this negative sign. Just you have to write Q, that is equals to 6.5 kilojoule, and in the bracket you have to write the amount of heat rejected, that is equals to 6.5 kilojoule, because Q value that must not be negative. If this answer was positive, in that case you have to write heat supplied is 6.5 kilojoule. Here it is with negative sign, so in the answer you have to write heat rejected equals to 6.5 kilojoule. This is a very important thing. So this is the end of this topic. I hope it is very much clear to you. Numerical is solved for you. You try to understand how to solve the numerical related to this part, and the last portion which is remaining, that you try to find out by your own, that is delta U value, change in internal energy. So you try to find out what is the delta U value for this polytropic process. This is the end of this topic. Do not forget to subscribe this channel, like this video, as well as share this channel name and this video with your friends. Thank you.